Hello, everyone. We decided to do our group project on a public speaking improvement app that we're calling Enunciate. We are Dawei, Jiaqi, Nick. We decided to choose this problem because glossophobia, which is the fear of public speaking, is a condition that affects 73% of the population, according to the National Institute of Mental Health. The idea behind glossophobia is that there's an underlying fear of negative evaluation from other people. For introverts, this can be particularly difficult to practice because the best way is really to practice in front of other people and receive feedback. In particular, in this pandemic setting, it's difficult to find in-person practice opportunities. And when we looked into virtual practicing tools, we couldn't really find many that were free and accessible to everyone. So we decided to build a mobile application that can provide quantitative public speaking feedback that we're calling Enunciate.
As with many mobile apps, there are a couple of key challenges that ours would face. For example, user privacy and data security. We understand that when the user uploads their speech, there may contain sensitive information in the speeches. As a result, we do not store any raw data on the device or in the cloud. And additionally, ML models are very difficult to train, especially voice recognition and analysis models. As a result, we will be using pre-trained models from AI labs or Google and IBM. And lastly, as we learned from the class, there are many limitations with regards to the technology, specifically computing and internet. We know that voice data take a lot of computing power to process and they're also very large. So we will be packaging the data and processing it in the cloud. And as for the timeline, first, we will design the basic UI UX wireframe, which includes a React Native frontend and Flask Python backend. And then we will add the basic functionality of recording audio files and analysis of poor speech patterns using the My Voice Analysis library, which is built in an AI lab in Japan. And lastly, we would implement the speech recognition for analysis purposes or articulation. And so far, we have tested Google Speech Recognition API, IBM Voice Recognition API, and other libraries. And then we will also use cosine similarity to compare the speech with the text that's been transcribed by these APIs.
So with our current progress, we decided to split this into front end and back end. We decided to use React Native because we have some JavaScript experience, and also the app can be compiled for iOS and Android devices. So here's a very basic user interface that we decided to come up with, where the user can record their speech, and immediately afterwards we process it and give results where we talk about irregular pauses, any filler words they use, and their volume, and give them a total score. And as Nick said, we do not store raw data. So we will store these processed results, and the users can look at the progress tab to associate their score with the recording date to see progress in their public speaking skills.
So talking about our backend implementation in Python. So first, if you look at the left, you could see a flowchart that would give you a sense on how we would like to structure our program. So you would first have a front end that would be actively communicating with the Python web server backend. The front end will be passing an input in the form of an audio and text file into the backend for processing. And after processing, some output would be sent back to the front end to be displayed on the user interface. And while this backend processing is happening, the Python web server will be actively communicating with the IBM Voice Recognition API to transcribe the audio file into text for easy comparison with the text file input. So some main libraries and APIs that we will be using have been explained well by Nick. And we will also be using an LTK corpus for cosine comparisons. And some next steps that we would like to take is to, of course, first build a Python web server with Flask, and secondly, to tie together the backend with front-end well to make sure that information exchanges between those two could happen seamlessly. And if we have time, we would also like to add more functionalities to the backend, such as giving the user recommendations on how to improve their speech, so forth and so on. So this is a demonstration of the backend that we have so far. First, the program would take input in the form of an audio file and a text file. And then this program would transcribe the audio file into text with the IBM API. So if you were to look at this graphic to the left, you could see that the audio text and text itself have been displayed on the screen. And after comparisons between the two happen, it would give you key metrics such as accuracy with code sign comparison, the balance, the articulation, the rate of speech, so forth and so on. Thank you.